The U.S. Air Force has permanently established its first overseas operating location for the RQ-4B Global Hawk Block 40 in Japan, assigning 3 of the high-altitude unmanned surveillance aircraft to Yokota Air Base. Operated by the 4th Reconnaissance Squadron, the deployment replaces the previous practice of temporary rotations with a sustained, year-round ISR presence. Positioned in Japan, the Global Hawks will enhance the United States' ability to monitor the Western Pacific, particularly Chinese activities in the region. The decision underscores Washington's increasing focus on maintaining continuous domain awareness and improving strategic monitoring as military activity and geopolitical tensions continue to intensify throughout the Indo-Pacific. In this video, Defense Updates analyzes why China will have nowhere to hide with American RQ-4B Global Hawk monitoring from Japan. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Before relocating to Japan, the 3 RQ-4B Global Hawk Block 40 aircraft operated from Andersen Air Force Base on Guam. While Guam offered a strategic forward location, its greater distance from key surveillance areas increased transit times, reducing the amount of time the aircraft could spend on station. Operations were also frequently challenged by the island's seasonal typhoons, which disrupted flight schedules and affected aircraft availability. To sustain the new permanent mission, roughly 150 military personnel have transferred to Yokota, equating to an average support contingent of about 50 personnel for each aircraft. Each system is thought to cost around $220 million, more than twice the cost of F-35 fighters. The U.S. Air Force currently operates 11 RQ-4B Block 40 aircraft, making it the only Global Hawk variant that remains in frontline USAF service. Older Block 20 and Block 30 aircraft have largely been retired, converted to other roles, or transferred to test missions. Basing 3 of them in Japan means roughly 27% of the USAF's Block 40 inventory is now positioned in the Indo-Pacific. The RQ-4B Global Hawk Block 40 represents the most advanced operational variant of the U.S. Air Force's high-altitude, long-endurance, unmanned aerial vehicle. Designed primarily for wide-area intelligence, surveillance, and reconnaissance, ISR, the Block 40 significantly differs from earlier Global Hawk variants by prioritizing radar-based ground surveillance rather than multi-sensor intelligence collection. Powered by a single Rolls-Royce F137RR100 turbofan engine producing approximately 7,600 pounds of thrust, the RQ-4B Block 40 is capable of operating at altitudes exceeding 60,000 feet while remaining airborne for more than 30 hours. Its large 130.9-foot wingspan provides exceptional aerodynamic efficiency, enabling the aircraft to monitor areas measuring hundreds of thousands of square kilometers during a single mission. The aircraft has a maximum takeoff weight of approximately 32,250 pounds, 14,630 kilograms, and carries an internal payload of up to 3,000 pounds, 1,360 kilograms, allowing it to accommodate sophisticated ISR equipment while maintaining long endurance. High-altitude operations place the aircraft well above commercial air traffic and many conventional air defense systems, maximizing sensor coverage and operational flexibility. The Block 40's defining feature is the ANZPY-2 MPRTIP radar, one of the most advanced airborne surveillance radars developed for unmanned operations. Unlike conventional mechanically scanned radars, the AESA architecture electronically steers its radar beams almost instantaneously without moving parts, providing faster target acquisition, greater reliability, and the ability to perform multiple surveillance functions simultaneously. The radar combines synthetic aperture radar (SAR), imaging with ground moving target indicator (GMTI) capabilities, allowing it to generate high-resolution imagery of stationary objects while simultaneously tracking moving vehicles across extensive areas. This dual-mode operation enables commanders to observe changes on the battlefield in near real time without sacrificing image quality or coverage. The SAR mode enables the Block 40 to produce detailed radar imagery regardless of cloud cover, smoke, haze, or darkness, conditions that often degrade electro-optical sensors. By processing multiple radar returns as the aircraft flies, the system synthesizes a much larger antenna aperture, producing imagery capable of identifying infrastructure, terrain features, and military equipment with remarkable precision. Simultaneously, the GMTI function continuously detects, classifies, and tracks moving ground targets, including military vehicles and mobile missile launchers. This persistent tracking capability is particularly valuable during large-scale military operations, where monitoring the movement of enemy formations is often more important than collecting isolated high-resolution images. The aircraft's mission systems are supported by secure satellite communications and line-of-sight data links that transmit sensor data directly to ground stations and operational headquarters in near real time. Advanced onboard mission computers pre-process collected information before dissemination, reducing operator workload while accelerating the intelligence cycle. Operators located thousands of kilometers away can dynamically retask the aircraft during flight, directing its sensors toward emerging targets or adjusting surveillance priorities as battlefield conditions evolve. This network-centric architecture enables the Block 40 to function as an integral component of modern joint command and control systems rather than merely serving as an isolated reconnaissance platform. The combination of endurance, altitude, sophisticated radar technology, and advanced communication suite makes RQ-4B Block 40 one of the most capable airborne ISR platforms currently in service. It enables the aircraft to conduct strategic surveillance missions that would otherwise require multiple aircraft operating in coordinated formations. Basing the platform at Yokota Air Base significantly enhances the U.S. military's ability to conduct persistent ISR over the Western Pacific. While the aircraft would not enter Chinese airspace, it will be able to monitor military activity from international airspace around the East China Sea, Yellow Sea, and the Philippine Sea. One of the biggest advantages is reduced transit time. From Yokota, the Global Hawk can reach areas around the East China Sea, the Taiwan Strait, and the Korean Peninsula much faster than if it departed from Andersen Air Force Base. So, Yokota's location is ideal for observing activity around several strategically important regions. The aircraft's AESA radar is particularly suited for monitoring Chinese military activities. Unlike electro-optical sensors, the radar functions through clouds, rain, haze, and darkness. Its GMTI mode can detect and continuously track large numbers of moving vehicles over wide areas, while its SAR mode produces detailed images of fixed installations. This allows operators to monitor the movement of armored formations, missile transporter erector launchers, TELs, logistics convoys, and activity at military airfields even during poor weather. The radar can repeatedly scan large ocean sectors to locate and follow surface vessels. Persistent radar coverage enables analysts to identify changes in Chinese operational patterns. Another key benefit is integration into the broader U.S. and allied ISR network. Data collected by the RQ-4B can be fused with information from satellites, Boeing P-8 Poseidon aircraft, Boeing RC-135 Rivet Joint, Boeing E-7 Wedgetail, and Japanese surveillance systems. This multi-source fusion provides commanders with a much more comprehensive operational picture than any single platform could generate.